Hello, everyone. Welcome back to our math series. Today, we're diving into telescoping series, a super handy trick that makes solving long sums really easy. A telescoping series is like a disappearing act in math. Most of the terms cancel out, leaving only a tiny part to solve. Telescoping series questions are very popular in primary school math Olympiads. They test your ability to spot patterns and simplify sums quickly. Let's look at some real examples from past competitions. This is a question from the 2015 Raffles Math Olympiad. Notice that all the denominators are sums of multiples of 31. We can rewrite the equation using some basic math operations. This question becomes very similar to the example in our last video. Let's quickly solve it together. With these two key formulas we learned before, we can transform any such equation into a telescoping series. Using our second formula, we can transform this into a telescoping series that's much easier to solve. Now we have a telescoping series. We can easily get the answer. Did you get it correct? Let's look at two more similar examples. Take a few minutes to try them out. Let's move to a slightly different question. Calculate the sum of the below equation. The key is still to uncover the underlying telescoping series. Observing the equation, can you identify the pattern? Let's pick up the first term. The top becomes 1 squared plus 1 plus 1, and the bottom is 1 times 2. This pattern repeats for all terms. Let's pay close attention to the pattern. Let's denote the nth term as Tn. For nth term, the numerator is n squared plus n plus 1, and the denominator is n times n plus 1. We can simplify the fraction. You might have noticed the similarity between this question and the previous example. We can apply the same formula. Now that we have derived our formula for the nth term, we can simplify the original sequence. Now we have got our telescoping series. Let's solve it. Let's move to another question. Recall that in all our previous examples, we applied the same formula. The key pattern is that all numerators are 1, and denominators are the product of two consecutive numbers. However, in this question, we cannot spot the same pattern. Here's a variation of this formula that might be useful. If you're interested, you can try to prove it yourself. If we can transform the denominator into a product of two integers whose difference equals the numerator, we can form a telescoping series. Let's start with the first term. 36 can be expressed as the product of 4 and 9, and the difference between 9 and 4 is 5. If all the other terms share the same pattern, we will have a telescoping series. Now let's transform the second term. It can be expressed as the product of 9 and 16, with a difference of 7. Let's continue with the remaining terms. One hint is that to form a telescoping series, the second factor of the previous term must be the first factor of the next term. This can save you time when breaking down the larger numbers. Now we can apply our new formula to transform the question to a telescoping series. Let's recap what we've learned today about telescoping series. In this video, we learned how to transform a number sequence into a telescoping series. The fundamental technique is to convert each term into a subtraction that can be canceled out by the subsequent term. We learned two important formulas that are helpful for solving various math Olympiad problems. Great work today. See you next time.